questions to help practice with initial amounts, rates of change, and writing equations for the graphs. So if we look at our first graph, the way we would figure out our initial amount, we just have to look at the y-intercept, where our line touches the y-axis. And in this case, it's at 12. So our initial amount is 12. Rate of change, we just have to determine, okay, so for every one across, how much does it go down? So when it goes one across, it goes down 2. So we know that it's, we know it's rise over run. So if you see a line going downwards, the rise is going to be negative. So to go over 1, it's negative 2 over 1. So our rate of change is going to be negative 2. And when writing the equation, we're going to just put, we'll put t for total equals negative 2 negative 2, we'll use n plus 12. So basically whatever our value is for time, multiplied by negative 2 plus 12. So for example, if it's 1 times negative 2 is negative 2 plus 12 would be 10, so it should line up with 10. So this would be our equation. Okay, same thing for the next one. We look at for our initial amount, we see it's 8, okay, because it's the y-intercept. Rate of change, we see, okay, after 1, it went down 4. So rate of change would be negative 4. Equation, total equals negative 4n plus 8. Okay, and you can use any letters for variables here. I'm just using these letters, okay? You could have put the height equals negative 4 times t plus 8. Okay, initial amount here, 12. Rate of change for 1 across, it goes down 1, so it'll be negative 1. Equation, total equals negative 4, or sorry, I don't know, the last one was negative 4, this one's negative 1. And we can just put negative n, because negative, whatever our value of our time is, plus 12. And here, last one, initial amount, we look at our y-intercept, okay, it's 8, every one across, it's going down by 1. Again, just like the previous one, so it'll be, again, negative 1, because you always have to pay attention to the scale, right? And then also how steep our line is. So it's about the same as the previous one. So we know that for every one, it's going down 1. Let's see. So it'll be the same as our previous one, but just a different initial value. Okay. Now we have to actually draw our own graph. So the bear driver appears to be commuting slow at a constant rate of 1 centimeter each 30 minutes. So we can say our equation is, we can use different letters here. We'll say the height of the snow equals, so it's 1 centimeter per 30 minutes. So we're doing per hour though. So we're going to be 2, because if it's 1 per 30 minutes, it'll be 2 centimeters per hour. 2 times h. So however many hours there are, multiplied by 2 will give us our equation. Let's graph this, okay? So after 1 hour, it'll be 2. After 2 hours, it'll be 4. 3 hours will be 6. That's enough. I'm going to just draw our line. So this would be direct variation. Our next one is snow pile 5 centimeter deep, accumulates snow at a constant rate of 2 centimeters every 120 minutes. So we know there's 60 minutes an hour. So that's going to be 2 centimeters every 2 hours, okay? And we can change that to 1 centimeter per hour. Gives us 5 centimeters deep, so we know it starts at 5. And then every hour it's going to increase by 1. Every hour increases by 1. Okay, that's all I need to put. I can easily graph this now. So basically you just have to look at the information it gives you. Next one, a snow pile 1 centimeter deep accumulates snow at a constant rate of 3 centimeters every hour. So it started at 1, that's our initial value, and every hour goes up by 3. So before, then 7, then 10. Again, we can just graph it. Just line it up. There we go. And then our last one, a snow pile 6 centimeters deep accumulates snow at a constant rate of 4 centimeters every 5 hours. So this is going to be a little more difficult, but what we can do, we just have to graph it. Well, we need our equation soon. I'll do that shortly. But let's just graph this one. So it starts at 6, and after 5 hours increases by 4. So we can just go 5 hours. 4 more than 6 is 10. It'll be right here. And you really only, if it's a linear, you only need 2 points to graph. So that's what our graph would look like. Okay, our equation here. Our height is, we know it's increasing 1 per hour, and it starts at 5, so it'll be, I'm going to use T instead of H for time. So however many hours it is, plus 5. Our height is, we know it's increasing 3 per hour, so 3 times how many hours, plus 1. And then our last one, this one's a little more tricky. Our height will be, since we know it's rise over run, so our rise here is 4, our run is 5, so rise over run times time plus 6. Okay, sorry, I didn't quite see that one, but again, our height will be, so we know that our variable rate is rise over run. We know it's increasing by 4 centimeters in 5 hours, so our rise is 4 centimeters, our run is 5. So rise 4, run 5 times hours plus 6. So these are our equations.